This video looks at some of the problems from section 3.3 of MA 104. For these first several problems, we are given these particular functions, f, and in some of the other problems, g. We're asked to look at these functions. We're given information about their domains and their ranges, and we are asked to use those particular pieces of information along with the idea of shifting functions to sketch the graphs of the functions that we are given in the individual problems. So for number 11, we are asked to sketch h of x, which is described as f of x, so here's my function f of x, plus 2. This plus 2 is added on to the end of the function. It's not incorporated into the function itself. So that means that it would be a vertical shift of 2 units up. I can look at the points on f and shift several of them 2 units up and then just use that to get the shape of my new graph. So here's a function, or here's a point on the function f. If I shift that 2 units up, that would put me right here. Another point that it passes through is the origin. If I shift that 2 units up, that places me here. Same with the point right here. I can shift that 2 units up. And then the points at the top and the bottom of the curve, if I shift those 2 units up also, just to sort of give me an idea of where my graph is going to be. So this point came up to, this point came up to. Then if I follow those, this can be the sketch of the graph of my function h of x. Next, I'm asked to look at this function g, and again, my shift is 2 units onto the end of the equation. The function itself has not been touched, so everything gets shifted up 2 units. I'll look at these individual points, some of these changing in direction points and the starting point and the ending point, and shift each of these 2 units up to give me a general idea of what the graph is going to look like. So if I start with that point -2, 1 and shift it 2 units up, same thing with the point -1, -1, I can take that with a vertical shift 2 units up. Same with 1, -1, bring that up, and here as well. Follow the pattern. Here is my function h of x. For this particular shift, we're asked to shift 2 units, but the -2 is now incorporated as part of the function itself. It's into those parentheses with the domain value, which means that it's going to be a horizontal shift. The -2 indicates a shift of 2 units to the right. So each of these points, I'm going to shift 2 units over to give myself a better idea of what the shifted function is going to look like. So the point -2, 0 becomes 0, 0. The point 0, 0 becomes 2, 0. The point 2, 0 becomes 4, 0. The point -1, 2, or approximately -1, 2, becomes 1, 2. And the point 1, -2 becomes 3, -2. If I follow that pattern, follow that shape of the graph, this can be my function f that has been shifted 2 units to the right. So this is my new function h of x. Same for g of the quantity x plus 2. Because that plus 2 is incorporated as part of the function, it's a horizontal shift. The plus 2 indicates a shift of 2 units to the left. So all of those points are going to get shifted 2 units to the left. If I use some of those points as a guide, then I can take the point -2, 1, shift it 2 units to the left to become -4, 1. The point 2, 1, I can shift to the left to become 0, 1. The point -1, -1, I can shift to the left to become -3, -1. And the point 1, -1 can get shifted 2 units to the left to -1, -1. Connect the points with the general shape of the function, and this is my new function h of x. Finally, we are asked to take the opposite of f of x. This minus sign indicates a reflection. In other words, all of the y coordinates have their signs shifted. Kind of shift this a little bit. There we go. So for this idea, all I want to do is move the points to the other side of the x-axis. The points that are on the x-axis will remain on the x-axis because there's no shifting them or there's no reflecting them since they're already on that x-axis. But if I take a look at a point like -1, approximately -1, 2, I can shift that to the other side and it will become -1, -2. Same thing for the point 1, -2, I can shift it up to become 1, 2. So when I do that, this point comes down, this point goes up, and then everything just gets shifted to the other side of the x-axis. It's as if I took that function and flipped it upside down. So this is my new function, h of x. We're asked to sketch these functions now using our parent functions and using the idea of a shift. For number 47, h of x equals the absolute value of x plus 2. My parent function is the absolute value function. Because the plus 2, or because that shift occurs as part of what I'm taking the absolute value of, it's part of what's with the domain, that indicates a horizontal shift. So every point of that parent function will be shifted 2 units to the left. The plus 2 indicates a shift to the left. We know that the parent function, h of x equals the absolute value of x, passes through the origin. So my new function will pass 2 units to the left of that. If I follow the shape of the absolute value function, and again, this isn't perfect, but it just gives me a general idea of what that function h of x will look like on a graph. My parent function for p of x is the square root function. I know that the square root function has that shape where it starts at the origin, and then it goes up into the positive y values. If we look at this particular function, p of x equals 3 minus the square root of x, that minus sign is with the square root of x. That indicates a reflection. The 3 is kind of added on to it. If it helps, you could rewrite this function p of x as p of x equals the opposite of the square root of x plus 3. I just commuted those terms. I switched the terms places. I kept the signs with them. I kept the negative with the square root of x, and I kept the plus with the 3. But written this way might make it a little bit easier to see what's happening here. The minus indicates that all of the points are going to be reflected. We're going to move those points to the opposite side of the x-axis. The plus 3 indicates a shift of 3 units vertically, 3 units up. So my point that was originally 0, 0 gets shifted 3 units up to become 0, 3. Everything gets reflected, so instead of my graph curving up, it will curve downward. My parent function for 55 is the quadratic function, the squaring function. It's f of x equals x squared, but for h of x, I'm taking that x squared, and then I'm adding 3. The plus 3 is not part of what I'm squaring. Since it's not part of what's actually being done with the function, it indicates a vertical shift. So my origin, or the point that passed through the origin, 0, 0, gets shifted 3 units up. And then we know that that quadratic function, or that x squared function, has the parabola, or the u shape, which looks like this. Finally, for n of x equals x plus 2 quantity squared, the plus 2 in this case is part of what's being squared. The parent function is still that quadratic function, that squared function. But now the plus 2 is not added on to the end. It's actually added in as part of the domain. It's part of the function itself. It's part of what's being squared. That indicates a horizontal shift. The plus 2 means a shift to the left. And then I just continue very roughly with that parabolic or U shape.